So the standard deviation is the average or mean distance from a data point to the mean. Sort of, not really. We actually computed the average squared distance they were from the mean, and then we took the square root of that final result. We didn't actually take all the distances and average them, but it can be thought of that way. That's okay. It can be thought of as how much a typical data point differs from the mean. Okay, so we have these two formulas given here just so that we have an understanding of what's actually being computed by technology when we compute these values, but you should always be using technology to compute standard deviations and variances in this course. We will never be computing those by hand. Similarly, for the population variance, we've got the symbols sigma squared and sigma instead of s squared and s. And we'll also notice a difference in the denominator here. So now we don't need something that's going to be a good estimate for the population standard deviation or population variance, because we actually have the population standard deviation or population variance. So our denominator here is just cap n. We don't have an n minus 1. So again, in the case where we would have been given actual population data, which is rare, again, we should always be using technology to compute these values. Again, we're not going to be computing population variances or standard deviation by hand either. So the value of s from the sample is used to estimate the value of sigma for the population, just like x bar is used to estimate the value of mu. So when we're given a data set, it is almost always sample data. So you should always be using technology to compute these values in this course. Okay, so I've said that 3 times now.